Today I wanted to talk about the full automation of the software development lifecycle. In the background, when you look at this video, you can see I have my terminal going there. I'm going to explain that in a moment. So doing a fully automated software development lifecycle is now possible. I think people have been doing this for a while, but there's kind of an emerging consensus on social media about certain pillars or techniques that must be used in combination in order to make this actually work. So speaking as a professional software engineer, I'm very, very senior. I've been programming for my entire life. I regard what's happening with AI right now as the single biggest change in software engineering I have ever personally witnessed. The advance in the tools are dramatic. It's much larger than things like having like LSPs and TypeScript and Rust and sort of modern things, VS Code and all the. I mean, modern IDEs, if you remove AI, are really not all that different from the IDEs that existed in the 1990s. They're better. I mean, don't get me wrong. I certainly wouldn't want to go back to the 1990s in terms of the IDEs and that sort of thing. However, AI is just dramatically bigger than any of that stuff. So the state of art with AI is now at least tenfold bigger. It's at least an order of magnitude better than all techniques we were using previously. And I've now been able to, in the past week, develop a workflow for fully automated software development. Now, the way this works is, again, speaking as a professional software engineer here, okay, I'm not a casual vibe coder or something, all right? I love the idea of vibe coding. I think it's a bit almost like it makes it seem a bit silly, but the idea of using AI, I'm very much in favor of this because we just have too many problems to solve for me to solve this all by myself. If I can get the AI helping me, I want the AI to help me. So I've been able to go from, the evolution of AI was something like, plugging something in the chat GPT, using tab completion with GitHub Copilot. Cursor was slightly more advanced. Then we ended up in this AI coding tool era. And I now use OpenAI Codex and Claude Code. And there are others. I don't want to say these have to be the best ones, but these do seem to be the ones that are the most popular. Most people are using these. I use both of them because I will have one review the other. And in the previous week, I finally achieved a personal goal of mine, which was getting the AI to run all night long and actually solve a problem correctly. So last week, I think it was between Tuesday and Wednesday, I had it solve a problem for me, and it did it correctly, and it was extraordinary. It was an enormous amount of work, and it did it in 7 hours, literally while I was sleeping, which was a personal goal that I had set. And so I've achieved this personal goal, and even from then until now, I've actually improved my workflow even further. And so I want to show what I'm doing. So on this project we see in the background here, I'm having it go right now. It says it's been pursuing this goal for 7 hours and 6 minutes. It's still going. The goal it's doing right now, let's refresh this editor here and see. So it's now on experiment number 45. It's on 45 experiments. And what I'm doing is in this particular experiment, I'm re-implementing libghosty, which is a Zig-based terminal library, into Rust. And I'm calling it Roasty. So it's creating libroasty, the Rust version of libghosty. Now, as you see, this terminal that I'm using is actually a terminal called TermSurf. I created TermSurf as a fork of WesTerm. It's a long story. You can read about it on the TermSurf blog, termsurf.com. I use this terminal as my primary terminal. For various reasons, I've decided WesTerm does not have the right architecture. I've had to struggle with some of the pieces of making it work with WesTerm. So I've decided to switch to Ghosty, but I really want to keep using Rust. And Ghosty's written in Zig. So I've decided, well, since the Bun guy, Jared Sumner, proved that he can rewrite Bun from Zig into Rust, I'm running another experiment and I'm rewriting Ghosty from Zig into Rust. And it's going right now. So I want to explain my workflow because the way I've solved this is really quite helpful if you're a software engineer like I am. So on the left side, you see what I call an issue. And the issue always basically has a description and a goal like this. Very similar to anything you would do. You put an issue on GitHub. We use Monday at my company. You might use Jira or something like this to track your issues. However you're tracking issues, you got an issue. The issue is here's this thing you need to solve. Last week, I had it solving a single experiment for me automatically, but I now have it solving an entire issue. So I've now gotten to the level where I don't even have to design the experiments. I say solve issue number 801, and then it will just go for as long as it needs to solve the issue. Now, in order to do this, you have to put all sorts of systems in place. Basically, it all becomes about context management. You have to have accurate context, and so you have to guide the AI agent with what you want. And the overall scaffolding of this amounts to something like making a bunch of decisions about things like dependencies, programming languages, and architecture up front, having those decisions made, having those decisions documented in places like agents.md files. And then what you do is you create a crystal clear issue like this, write down what the goal is, and I have a skill called issues that describes this workflow of the way we solve problems is we create an issue. We don't always know how to solve the issue, so we're going to take our best guess, and what we're going to do is we're going to create an experiment. We might need more than one experiment. We're going to start with the first one that's going to solve either the entire problem if we have a hypothesis that might solve the entire problem, or we solve just one piece of it. Experiments can succeed or fail. They usually succeed, but sometimes they fail. It depends on what you're doing. You might have an idea about how to do it that's wrong. It might fail. Looks like most of these are passing. In fact, it looks like every single one of them that I can see is in a pass state. So it's being a little bit modest, I think. I think it's doing it's not being super ambitious. It's creating bite-sized, achievable experiments. But I used to design these by myself, but now what I do is I have the AI design them. And this is extremely critical. So for each experiment, I'm going to go do a GF here. You can go to the file and actually look at the actual experiment, and it will design each experiment, execute the experiment. Each experiment has a state. It has to go through designed and then pass and so on. And it gradually works its way up to all issues. So I'm going to look at this file. So we've got, each experiment gets its own markdown file. There's a README file. I have an issue folder like this where I keep track of all the issues. There's currently, there's not actually 801 because there's some missing numbers there, but there's like 300 or so issues. So you go into 801. This is the latest one. Lib goes to rewrite, lists all the files, open up README, and look at it. But fundamentally, the way I do this is you get to the point where you literally just type in something like goal solve issue number 801, and that's what I typed in, and now it's going, and it's been going for 7 hours, and it's doing it productively. Now, this one's in progress, so I'm not sure if this one's going to work out. I think it probably will because I've done this enough times now that I'm convinced this is going to work. But I've done it in the previous week now. I've had this going several times. I'm able to get it working for many hours at a time and solve a problem. This is extraordinary. I mean, throughout my entire life, I'm a highly technical person who's always been about solving problems. I'm either a software engineer, I was a physicist for a while, I was also a CEO. I'm now a software engineer once again, and I just build apps all the time. So all the problems I'm solving are related to apps. This isn't really strictly limited to apps. You can just solve problems. We now have general-purposed problem-solving machines. So this is a full workflow. Oh, and one more thing. So let me just give you a couple of pieces to the puzzle if you want to try to set this up yourself. You have to have tests. You have to make sure that it knows that it needs to create and maintain those tests. You have to have documentation, make sure it maintains with docs. Make sure you have things like type checking, formatting, linting, this sort of thing as needed. Depends on the programming language. But do that sort of thing. The other piece that I didn't know until recently, but it makes all the difference in the world, you have to have some sort of adversarial review. The way I do this is for each experiment, when it designs an experiment, it has to get another AI agent to review it and sign off on it before it's done. So it'll create the experiment, have a second agent review it, and then it has to fix it and get the second agent to review before it does the experiment. And then after it runs the experiment, succeed or fail, whatever, it has to get the second AI agent to review it and then sign off on it once again. So we've got many reviews going on. So we got a review at the start and a review at the finish for every single experiment. And so that means if we got 46 experiments, we have 46 times 2 equals 92 different reviews going on. So to get to this far, we've had 92 reviews, and every review has to pass before it can move on to the next cycle. I believe this was the final missing piece for total automation for me. By having a second AI agent do the review, it turns out that the state-of-art AI models and harnesses are good enough that that's all you need to keep the first AI agent on track. If you just incorporate adversarial review, in addition to all the other things you're doing, you can get it to run for many hours productively and solve an actual problem for you. So in essence, what you have to do, and what I've done in the past week and what other people are doing on social media, in their jobs, in their side projects, whatever, you actually embed the entire software development lifecycle inside the AI agent for each task. So in the same way that if I were not using AI, I would write code, I'd get a fellow engineer to review my code before it can be merged into the main branch. Almost every company does it like this. You build that exact same cycle into the AI agent itself. It does an entire software development lifecycle internally before it's done. Okay, that's enough for today. In conclusion, we seem to be literally living through the singularity. We're in the positive feedback loop. This is what Ray Kurzweil was talking about. It's incredible. The state of art of AI tools allow me to do fully automated problem solving. That's extraordinary. It's not just for software. I'm using it for software, but it can be used for anything in principle. So we're in a new world, and the basic trick here is you incorporate the entire software development lifecycle into the AI agent per task. And the latest generation models and latest generation harnesses are good enough that you actually keep the AI agent on track for the entire duration. And I've successfully solved problems for 7 or 10 hours. This one's probably going to go for 15 or 20 hours or something. We're going to see. But I've proven this last week. It absolutely works, and other people are doing this too. So we've achieved another milestone in the rapidly changing world of AI. Fully automated software development lifecycle is now a daily reality for many of us engineers. Okay, thank you very much for listening.